Greetings of today. In this video, I'll be discussing the second simulation program in Computer Networks Laboratory with the subject code 18CSL57. The problem statement is implement the transmission of ping message or trace route over a network topology consisting of 6 nodes and find the number of packets dropped due to congestion. We are simulating given problem statement using NS2 and we consider ping message for the same. Before going into the simulation part, we will see what is the ping message and what is the purpose of ping message. The ICMP echo request and ICMP echo reply messages are commonly known as ping messages. ICMP stands for Internet Control Message Protocol, which is used for identifying and transferring the error messages in the network. And ping is usually utilized for troubleshooting by the administrators to manually test for connectivity between the network devices, and also it is used for testing network delay and the packet loss. For example, if you have a device and if you have a server, that is client and server, normally we will be using ping message or ping command to test the connectivity between two systems. The client will send a ICMP echo request for the server and the server will reply back with the ICMP echo reply. With this, the ping will test how many number of packets are sent and what is the delay between the two devices based upon the round trip time, that is RTT. This is the sample output of the ping command. The ping is the command name and followed by the URL whatever we want to test. So here is the how we have to use the ping command. Here I am testing how to geek.com with the ping command. Once we run the command, it will send some, the client will send some of the ICMP echo request messages with 32 bytes of data and it will receive reply. And here you can see it is showing time and the TTL. So time is nothing but round trip time and TTL is nothing but total time to live. And this is a summary of whatever the ping command we have run. So totally 4 messages have been sent and 4 messages have been received. So it is showing lost is equal to 0. And approximate round trip is also calculated in terms of millisecond. The ping command can also be used for testing the connectivity between the system to the router if you know the IP address. Instead of URL, you can also give the IP address of the system to which you need to test. So here I have given the IP address of the router, local router, and I'm getting the result. As I told, ICMP protocol will be working behind the ping message or ping command. Whenever a particular device which you are testing is not able to send any response, then ICMP protocol will send the particular message for the user in order to understand the problem in the network. For example, in this case, you can see here, I'm trying to test or ping a device with IP address 10.0.0.24, but I'm not getting any response. That is why I'm getting the message with the destination host unreachable. So this is what the message sent by the ICMP. Like this, there are other messages will be sent by ICMP protocol based upon the situation in the network. Apart from this, the ping command can also be used with many other options. So in order to see the different options along with the ping command, you can use this command to get the different options along with the ping command. And you can also see the usage of those options. So open the command prompt in your laptop in Windows or Linux and just try ping command with the various options to get to know about the ping command with more details. In order to simulate this, I will be using Network Simulator 2, and along with that, I will also be using the NS2 tool for generating the Tcl script. The command for opening NS2 is java -jar nsg2.1.jar. So this is the initial page we get for NS2.1. So here we need to select the scenario. And the scenario I am selecting new wired scenario because I am going to develop a wired network. To go to wired scenario. And as per the question, we have to create a topology which includes 6 nodes. So select node option and place 6 nodes on the workspace. So place 6 nodes. So starting from N0 to N5, and I need to create a link between these nodes. So go to link option, and here you can select different parameters for links. The first one is link type. I am selecting duplex link, and queue type I am going with the drop field with the capacity 100 Mbps and propagation delay 10 milliseconds and queue size is 50. So this is the default value. I'll be choosing the same. Create a link from N0 to N3. So click on N0 first, you will get a green color, and next click on the other node, that is N3. A duplex link is created with the these information. And another link which connects N1 and N3 similar way, and then N2 to N3. Next, connect N3 to N4, and again connect N3 to N5. So this creates a topology of 6 nodes with the point-to-point link. Once the topology is created, next we can attach the agent to the sender and receiver. Here I will select N0 and N1 as my sender and N4 and N5 as the receiver. In this experiment, we have to choose ping agent, but in this NS2 we don't have any ping agent option. So what we can do is, first we will select the TCP agent here, and once we generate the Tcl script, we will modify the TCP agent to ping agent. That is the one shortcut method we use here. That is why we generate the Tcl script along with the TCP agent. Then we modify it. So select TCP under agent type. Let the packet size be 1500 bytes and attach it to sender. I am attaching to N0, this is the first sender, and attach one more to the second sender, that is N1. Similarly, select TCP sync and attach it to receiver. For N0 sender, my receiver is N4, and for N1, the receiver is N5. Next, connect this
sender to this receiver, click on TCP0 and click on sync 2. Now these two things are agents are connected. Similarly, connect TCP1 to sync 3. With this, we have finished all the things whatever we do in the NS2 2.1. We don't have any application because we will be sending the ping message. So here we don't have any ping message application. So we modify it in the Tcl script. So you can go to parameters. So let it be the simulation time as 10 seconds, and trace file you can change according to your wish. So as of now, let it be out.tr and nam file will be out.nam. So click on done. Next, click on Tcl to generate the Tcl script. So this is the Tcl script for your simulation. Save it. So here we need to save it as .tcl file. The file extension is .tcl. Give any name. So file type is .tcl. Save it. So just note down the location where the file is saved. My file name is ping.tcl. So once you have saved the file, you can close this particular application. Now here, this is my Tcl script which is generated by NS2 2.1. So NS is my object of simulator class, and this is the line for opening trace file and flushing all the information to the file. And this is the statement for opening nam file, pointed by nam file with the name out.nam, open in write mode. And this is a statement for setting the nodes, and these are the statement for creating a link duplexing between one node to another node with 100 Mbps speed, 10 millisecond propagation delay, and drop tail as the queue type. And the queue size as we have chosen, it is 50 queue limit. And this is the node position with respect to other nodes, statement to place the node. And here is the agent definition. So here, since we have created TCP, it is generated the statement for creating the TCP agent. Now we have to change it to ping agent. So here what we need to see, for attaching the ping agent, instead of TCP, we have to write it as ping. So since this is the case sensitive, we have to remember that we have to write as it is. So agent ping is my class, P is the capital, and we are attaching to variable TCP0. Here I am changing to one of the other variables. So in order to change the variable type, you can just go to view, search and replace. So wherever you have TCP0, you can make it as P0. So wherever TCP0 is there, I make it as P0. I am replacing all the TCP0 to P0, replace all. In the same way, change TCP1 to P1. TCP1 to P1, replace all. And I am changing sync2. So we have sync2 as my variable, sync2, P3. And I am also changing from P3 to P4. P3. So close it. So here it will be P3 or P2. Again it will be here P2. So that means I am creating 4 string agents here. P0, P1, P2 and P3. P0 and P1 are the sender, P2 and P3 are the receiver. And again I need to change here from P2 to P2 string. Again here string to string agent. Agent for string is the class of agent of the agent. Okay. So that's it regarding agent definition. So now I need to write the statement for application definition. So here at a particular interval of time I need to send a ping message. I need to send the ping message. The statement for sending the ping message is $ns, which is my global variable for simulator class object variable $ns at specify the time and specifying at 0.5. I need to send the first message, that is T0. So $T0 send. So like that I can also send multiple messages at the same time or in a different time. So I am sending 4 ping message at 0.5, that is T0 will be sending the 4 messages. So just copy and paste 4 times. And similarly we can send 4 messages for T1. So just copy paste 4 times and you can change this from T0 to T1. So totally 8 packets will be messages or ping messages will be sent at time 0.5. And here one more thing we need to add is the receive procedure. Since there will be a reply from the server to client regarding the RTP and other stuff, we have to include the receive function. This is the instant procedure which is defined inside the agent ping class. So we will be defining the receive function like this. So agent ping type is the instant procedure INSTCROC. The function name is RECV followed by 2 arguments, that is from, first argument is from and second argument is RTP inside the braces. And now we are writing the body of the procedure. So this body of the procedure uses one of the predefined variables, that is instant variable. So $self instant variable INSTVAR node underscore. So node underscore is the predefined variable which holds the node ID of the the receiver of the response. Then we need to print the message using footer. So node, particular node receives the response from the server with the particular RTT. That's what we are going to print. So here, in case of node ID to get, we need to represent the node underscore value, that is $node underscore, the value which is stored in node underscore, and the node ID. Please note there is a space between node underscore and ID. Receive the response from, so to specify the node ID from which particular node is receiving the response with the value of from. That is the first argument whatever you have passed for the receive function with total RTT value is equal to value of RTT. That is $RTT millisecond. Close. So close the instance procedure body. So that's it regarding the trace file. Sorry, the Tcl script. So we have included all the things. Now you can save it. Whatever you have modified, save it. And now we have to run this particular Tcl script. Close this. Go to command prompt and run the Tcl script whatever you have modified. To run the Tcl script, we use ns command. Ns, name of the file, .tcl. There is some error. Okay. So I have changed P3. So this should be P2. Save it. Run again. Okay, now I am getting the output. So this is a NAM file and we are getting the output. This is the output which I have got because of that receive function or procedure. So node 0 received response from node 4 with the RTT 40.3 milliseconds. So this is the node ID and this is the from node value and this is the RTT value. So like that, we are sending 8 messages. For 8 messages, we are receiving the output. That means we can say that there is no loss as of now. So just you can view the NAM animator. So just play. At 0.5 actually we have sending the messages, ping messages. You can see messages going from 0 to 4 and node number 1 to 5 and responses back to 0 and 1. So only at 0.5, 8 messages will be flowing in the network. So that's it. Other time the simulation will be ID phase. So we can close this and we can open the trace file. So to open the trace file, we should remember the trace file name. Open with gedit. The trace file was, the name was out.cr, gedit out.cr. So this is a trace file which is generated. Here you can see there are 12 columns with the meaning. The first column indicates the event. So plus indicates NQ, minus indicates DQ, R indicates the receive event, and if at all you have dropped, then D will be represented in the first column. This is the time, and this is the from node and to node. Packet type, that is string type, and packet length, that is 1500, This is a flow ID. As of now, we have not chosen any flow ID. It is 0. And this is a source node address 1.0, where 1 is the source node ID and 0 is the port number. This is a destination node ID and port number. This is a packet sequence number and packet type, packet ID. And if you observe here, this is the response message, whatever we are receiving. So now we have to identify number of packets dropped. So we can write awk program for this. So we need to generate the awk program for text processing. We'll close this and we'll write the awk program. And later we'll see how we can reduce the queue size, and if at all we reduce the queue size, whether we get drop of packet. So first we'll write the awk program. So go to gedit, awk program name ping.awk. So here we need to write awk program. Awk program will have 3 sections. First is the begin section. Begin, where we can declare and initialize some of the variables. So here I need to count the number of drop packets. That is, I take a single variable to count the number of drop packets. So count is equal to 0. I am initializing, and there is the only variable I am using. So close the begin section. So next, the second section, where I will be counting the number of drop packets with the help of first column. So if at all I have D in the first column of the trace file, then I need to count. So once I finish the count, then the value which is stored in that count will be the total number of drop packets. So to do this, I need to count how many number of these are there. So for that, I use if condition if $1 is equal to B, then increment the count. Increment the count value. That's it. And last is end section, where I will be printing the result using printf. Number of dropped packets is equal to the value of count, where it is integer. So I am using %d. So this is the awk program for counting number of drop packets from the trace file. So save this and remember the file name. Close this. Now we have to run this awk program for the trace file. The command for running the AWK script is AWK -f option. First we have to give the AWK script file name, that is ping.awk, whatever we have written, followed by the input file name, that is out.pr trace file. So run this. So you will get number of drop packets as of now is 0, because there is no drop of packets. Now we have to see how we can get the drop. So when we can get the drop, we have to analyze. So to do the changes, we have to open the trace file first. Open the trace file. Tcl Script ping.tcl. So we have to make changes here in order to get the drop. one way to get the drop is reducing the queue size. So in order to get the drop at the intermediate node, we have to reduce the queue size from the intermediate node, that is N3 to N4 and N5. So here I am reducing the queue size N3 to N4 to 2, and here I am reducing it to 1. So once I do the changes, there can be some drop of packet. We will see what happens after running the program. And here again we can also increase the size of the packet. So as of now I am not doing that. So just save it and run the Tcl script again by using ns command. So if at all you have drop, you can come to here whenever you see the NAM animator, just run here and you can see if at all there is a drop. Okay, so there is some drop of packets. So how many number of packets have been dropped? That we don't know because all the packets are moving at the same time, the same speed. So just you can close this, and now you can run the AWC script for the same, so that you can see how many packets are being dropped. So I am running AWC script for the same trace file. So you can see here number of dropped packets are 4. So actually dropping of packets is not good for the network efficiency. So just we will increase the queue size in order to prevent drop of packets. Again, if you see trace file, there will be some event where you will mention with the D. So that is the meaning of drop of packets. So again you can change the queue size to some other value so that you can prevent the drop of packets. So from 1 to increase to 2, save it. So increase the queue size from 1 to 2, save the file and run the file again. Okay, so this time I am not saying this, just I will run the AWC script directly so that we will get the number of drop of packets. Okay, so now we are getting drop packets are 0. So we can say that with for transferring 8 packets at a time, the queue size from 3 to 4 and 3 to 5, 2 queue size is enough for this particular network. So that is how we are analyzing the queue size for preventing the drop of packets. In the same way, we can also change the queue size from different nodes, and you can see the output. For the output, you can mention this as one of the outputs and the NAM file along with the output of the AWC script, that is number of drop packets.
Thank you for watching the video. We'll meet in the next video.